Welcome back to the 3 months of modal logic, a sequel to 100 Days of Logic here with Carneades.org. Today we're going to be continuing with November's focus on temporal logic, looking at the varieties of temporal logic. Over the last week or so, we've looked at 7 or 8 different axiomatic systems that you can choose for your temporal logic. In this video, we're going to do something of a summary of these different systems and positions so you can see, compare and contrast them, and decide which is best for your personal theory of time. So, which axiomatic system you use depends on which you think maps onto time the most correctly. If you think that time is dense, for example, you need to use either QT or RT. If you think it's well-ordered, you should use NT. The axiomatic systems are not really correct on their own. Their usefulness just depends on how well they map onto your own understanding and theories of time. In this video, we're going to offer a summary of these different positions on time so you can kind of decide for yourself which makes the most sense. So, the minimal temporal logic is referred to as KT. It includes just these axioms: the temporal modal logic necessitation rule, the temporal axiom KG, the temporal axiom KH, temporal axiom GP, and HF, remembering that GP and HF are kind of new axioms to temporal logic because they relate past to future, and they don't map onto other modal logics as well as a lot of the other axioms do. Next, building on that, we have the transitive temporal logic. This is going to include all of the axioms from KT and add a version of temporal axiom 4, or a version of axiom 4 from modal logic, which is GP implies GGP. And we're going to call that system K4T because it includes axiom 4 and adds axiom 4 to system K. Now, if we want our temporal logic to be reflexive, we're going to call it S4T, and we're going to include, alongside all of those other axioms, our temporal axiom T, GP implies P. Alright? Now, taking out that reflexive axiom and just going back to kind of what we had with our transitive temporal logic, we can move from that on to linear temporal logic, or LT. This is going to take those other axioms we had and add on the temporal axiom of linearity, basically saying that time is just staying in one straight line. It's not going to branch. All right? Now, if we want to move even farther than that, we can move on to well-ordered time, or NT, which is going to take all of those axioms we already had, with the exception of reflexivity, and add in the temporal axiom of well-ordering, the temporal forward induction axiom, and the temporal axiom of no end. Remembering that well-ordering means that any set of instants is going to have a least instant, even infinite sets. And temporal forward induction axiom is going to imply backwards discreteness. And of course, the temporal axiom of no end means that time has no end. It's easy to remember and understand this system when you remember that it maps onto the natural numbers. All right? Next up, we're going to have inductive temporal logic. We're going to not use all of the axioms we had from the last one. We're going to get rid of well-ordering, but we're going to add in our temporal axiom of no beginning and the temporal backward induction axiom, which functions in the opposite way of the forward induction axiom, just as no beginning functions in the opposite way of no end. This is going to provide us with a system such that our instants are going to map onto the integers, that's positive and negative non-decimals, and 0. Now, if we want to go a step further, we're going to get rid of those induction axioms and say that time is dense to get our dense time, or QT. In doing so, we're going to need to add a new axiom. We're going to add our temporal density axiom, or GGP implies GP. Basically, this is saying that our time instants don't have immediate successors or predecessors. Time is dense. For any two instants, there's an infinite number of instants between those two instants. This means that time is actually going to map onto the rational numbers. Remembering, rational numbers are numbers that can be expressed as ratios. And finally, if we want to move past density and including everything from Qt, but adding in completeness, we're going to be able to get complete temporal logic, also known as RT. To get this, we're going to add our temporal completeness axiom, which basically is going to allow our numbers now to map onto all of the real numbers and to say that there are no gaps in our number line. There are no irrational numbers like pi, the square root of 2, or e hiding in there. There's no way we can define some set such that the way we're defining it is expressed in terms that aren't present in the set of numbers or instants that we have. All right? If any of those were confusing, please go back to the videos on those specific systems and you'll get a more in-depth picture. This is just kind of a summary at the end of all of those axiomatic systems to hopefully remind you of them and give you a bit of a chance to look at them side by side and see which axioms you like and which ones you don't. Up next, we're going to kind of move on from these axiomatic systems and start looking at some new tense operators. And in this one, we're going to be talking about the next time operator. All right? Watch a new video every single day for 100 days with the 3 months of modal logic here at Carneades.org. And stay skeptical, everybody.